Okay, so in the last video, we talked about solving problems with conservation of energy. And so now we're going to take a detour and talk about something else having to do with energy, and that is the concept of work. And I've mentioned work before, or basically work as energy that is added or removed from an object from an outside force. Okay, and so when we talk about work being done on an object, what we're talking about is we're talking about either adding energy or taking energy away from something. Okay, so work is not exactly energy itself. You cannot possess work, but work can be done on an object to either add energy or remove energy. Okay, and so the way that's done is by a force. And so basically, when you take a force and you apply it over a distance, that force can transfer energy to or from the object. Okay, now the equation for work looks like this. We have a capital W, that is the symbol for work, is equal to force, that's capital F, force measured in newtons, times distance, D, measured in meters. That's it. Okay, now work is not a type of energy exactly, but it's the transfer of energy. And so the unit for work is the joule. Okay, so we write capital J for joule, just like the other types of energy. And again, you cannot possess this many joules of work, but work can be done on an object. Now, from the equation, you can see that the factors that influence work are force and distance. So if you apply a force on an object, let's say you're pushing something, the farther you push the object, the more energy you transfer to that object. Okay, and so the factors that affect work are force and distance. Now, work does not have direction exactly, um, but remember, work is the transfer of energy to or from an object. And so you can have positive work or you can have negative work. Okay, so what is meant by positive work? Well, positive work basically means that a force is adding energy to an object. So for example, if I kick a soccer ball, my foot puts a force on the ball. The force is applied over some distance, maybe a few inches, okay, and the energy goes from my body into the soccer ball. The soccer ball gains kinetic energy and it starts to move. Okay, that's an example of positive work. Negative work, when negative work is done, that negative work serves to remove energy from that object. Okay, so a classic example of negative work being done is with friction. Okay, so we know if I kick the soccer ball is going to roll, but it's not going to roll forever, at least not if there's friction. Okay, so eventually it's going to slow down and it's going to stop because of friction. Okay, so friction is removing energy from the soccer ball. Okay, it's taking energy from the soccer ball, it's turning it into thermal energy, okay, but it's taking it out of the soccer ball, and so that would be negative work. Okay, and so you can figure out whether positive work or negative work is being done on an object based off of its energy going in or out of the object due to that force. Okay, and it's possible for more than one force to act on an object, and some forces might add energy, so some forces might do positive work, and then some other forces might do negative work and remove energy. Okay, so make sure you have that added to your notes, and then we're going to do some basic calculations with this. Okay, so example one. Example one says a woman pushes a shopping cart a distance of 16 meters. Okay, so this is my distance with a force of 20 newtons. Okay, so here's my force. It says calculate the work done by the woman. Very easy calculation. Work is just force times distance. And so that would be 20 newtons times the distance of 16 meters. So that would be what, 320 joules of work. Now, is this positive or negative work? Okay, so to answer this question, you have to think, is the woman adding or removing energy from the shopping cart? Okay, well, if she's pushing it along, she's probably like pushing it and making it go faster. Okay, so she's probably adding energy to the shopping cart. So based off of the context, you can infer that she is doing positive work. Okay, so whether positive or negative work is done depends on is energy being added or taken away from the object. Okay, so that is it for example 1. Pause there if you need to look at that some more. Okay, example 2. Example 2 says a car traveling down the road with 500 joules of kinetic energy. So now this is interesting. So we're given EK, and we're told that it stops over a distance of 25 meters. So we know this is distance, right? Because it says it stops over a distance. They give us the kinetic energy, and we're asked to calculate the force. Now, clearly, we have to be using the work equation. There's only one equation that has force in it. Okay, and we have distance, and so we have to think where is the force? Okay, this question you have to really think deeply about the concept of work. So remember, what does it mean for work to be done? Well, that means that energy is being added or taken away from the object. So think about this situation. Is the car losing energy or gaining energy? Okay, well, it's losing energy because the car is going to come to a stop. Okay, it says the car stops. So that means that at the end of the problem, the final kinetic energy is going to be 0 because it stops moving. Okay, so it starts with 500 joules of kinetic energy and ends with no joules of kinetic energy. Okay, so was work done on the car? Yes. Okay, was it positive or negative work? Well, it was negative work because the car lost energy. Now, how much energy did the car lose? Well, it started with 500 joules. Now it has 0 joules. So that means the work done by the car would be negative, because we're losing energy, 500 joules. Okay, and so this is partially a calculation question and partially a concept question. Okay, the concept is, do you understand that work is telling you how much energy you're gaining or losing? And in this case, if you read the problem, you can figure out we're losing 500 joules of energy. And now that we have the work, we can calculate the force, because then we can do negative 500 equals F times D, which is 25. We can divide both sides by 25, boop, boop. We get F equals negative, the force is negative just because it's making it slow down, and that's going to be negative 20 newtons. Okay, so that is example 2. Pause there if you need to look at that some more. Okay, so example 3. Example 3 says a toy car with a kinetic energy of 32 joules has a spring a spring inside of it which does 16 joules of work on the toy. How much kinetic energy does the car have after the spring does work? Okay, so see if you can figure this out. Okay, so once again, we have here a concept question. Do you understand the concept of work is to add or remove energy from the object? So let's think about this logically. Car starts with 32 joules of energy. There's a spring inside of it, which does 16 joules of work. Now, do you think that's positive work or negative work? Do you think the spring is adding energy to the car? Yeah, of course, because, well, I mean, hopefully you've played with those toy cars where you like wind up the spring and then you put it down and you let it go, and then it like, drives around or whatever. Okay, that's positive work being done. That's energy being added to the car. Okay, but the car already had 32 joules of energy to begin with. Okay, so if you start with 32 joules, you do 16 joules of positive work, right? That's 16 joules of energy added to the car. How much energy does the car have now? Well, that would just be 32 plus 16, which is 48 joules. Okay, and so that's the answer to the question. And the only way you can answer that is if you understand the concept of work. So make sure you understand the concept of work that we've been talking about. Okay, so pause there if you need to look at that some more. Okay, and this chart just kind of summarizes what we've been talking about. Positive work, object is going to gain energy, it's going to speed up. If the work is negative, car is going to lose energy, it's going to slow down. One other thing I do want to point out to you, though, is that if you have a situation where the object does not move, I want you to look at this. What would happen if the object does not move? So for example, let's say you push on the wall doesn't move, right? In other words, the distance that the wall moves is 0. What does that tell you about the work being done? Okay, well, if it doesn't move, the distance is 0. 0 times anything is 0, and so that means the work done would be 0. Okay, meaning if you're ever in a situation where you're applying a force but the object is not moving, that means that that force is not doing any work. It's not adding or removing any energy from the object. Okay, and so kind of keep that situation in mind because you might see that in the future. Okay, so you can have positive work, negative work, or zero work. Okay, and last example for this video, in which of the following examples is work being done? Okay, so let's say this is going to be A, this is going to be B, this is going to be C, and this is going to be D. Okay, so look at the question carefully and try to answer this question. In which of the following examples is work being done? Okay, well, based off of what we just talked about on the last slide, remember if an object is not moving, the distance it travels is 0, which means that force is not doing any work. Okay, so for A, box is not moving. B, weightlifter holds a barbell motionless above their head. Now they're going to get very tired, but technically speaking, they're not doing any work on the box because the box is not moving. Okay. D, a car sits at rest on a steep hill, not moving. Okay, so the only situation where work is actually being done is C, when the man pushes a shopping cart in the store. Okay, so in this video, we talked about the concept of work. Make sure you definitely understand that concept. We did basic calculations with the work equation. That's W equals F times D. And then we talked about a situation where a force can act on an object and no work is being done, namely that that force, namely that that object is not moving. Okay, so even though you're applying a force, the object doesn't move. Okay, and so that's a situation where there's no transfer of energy because there's no work being done. All right, as always, please let me know if you have any questions, and I'll see you guys in the next video.